NASA designs near-light speed engine that breaks the laws of physics. Someday soon, apocalypse will come to the Earth, and when it does, we will no longer have a habitable planet. For the human race to survive, we will need to leave Earth and relocate elsewhere. When you consider the size of our solar system and the immensity of space, it's certainly a complicated issue. No matter where in space we are heading, we must move there quickly, and not just at the speed of light, but rather at a much higher rate. To accomplish this, some scientists have created an incredible engine that defies the rules of physics, and now they are claiming that a warp drive, as we have seen in Star Trek, is feasible. Is this technology truly being developed by NASA? What does the future of space travel hold? And most importantly, is the procedure going against the laws of physics? Well, stay tuned till the end as we are going to talk about NASA's near-light speed engine design that is rumored to break the laws of physics. In this video, we will answer all those questions and more. Suppose Alpha Centauri, our nearest neighbor, is located 4.367 light-years distant. As a result, even if you could travel at the speed of light, it would still take 4.367 years for you to arrive. Although we could utilize rockets to go through space, the main drawback would be the weight of the fuel required, and like cars, rockets have a maximum speed at which they can propel a spacecraft. We're going to need a propulsion system capable of a lot of thrust and operating while carrying a lot of fuel. Remember, there are no petrol stations in space. The good news is, there is an engine that can propel a spaceship without using fuel. Additionally, this engine doesn't emit any exhaust. You simply plug it in, turn it on, and voila, it starts working. The EM drive, sometimes known as the impossible engine, is so named because it promises to be capable of performing the impossible. How does this EM drive function? From the side, it does initially resemble a rocket engine. The system, which functions by bouncing microwaves inside a confined chamber, has no openings whatsoever. The microwaves in the chamber are intended to primarily generate a push. This is significant because some degree of momentum conservation is necessary for all types of rocketry. You need to push off something to start a spacecraft moving. For instance, if you leap, your feet will push off the Earth, just as an airplane will push off the air, and rockets will use the exhaust from their engines to propel whatever they are carrying. On the contrary, there is nothing to push off with the EM drive. It's a container with moving microwaves inside it capable of moving itself. As you can see, this is why this engine is referred to as impossible. The explanation for how this object operates transcends our knowledge of physics. Nobody truly comprehends how it works. The device's testing may reveal that our understanding of physics is flawed or teach us something entirely new. In 2001, the EM drive's idea became a reality. Research teams asserted they had detected a net force emanating from their apparatuses. However, the effect they were tracking is exceedingly minute. It was too little to even move a piece of paper. So after almost 20 years, we are left with several trials that have not produced anything noteworthy or any explanation of how they operate. According to some experts, this initiative will never succeed, and all efforts will probably be a waste of time and resources. This object might not function due to limitations in our knowledge of physics or the existence of undiscovered new physics. However, there are other space engines in existence that many predicted would never function, but suddenly sprung to life. We're talking about the ion drive, a technology that, when it was first envisioned, was only considered imaginable in science fiction. Additionally, when a true ion drive was first described, people believed it would never be powerful enough to move a small spacecraft. However, the ion drive functions, and in 2016, NASA paid Aerojet Rocketdyne, a corporation based in California, $67 billion to design, construct, and test a sophisticated and incredibly efficient solar electric propulsion system, or SEP. Additionally known as a Hall effect thruster, this driver uses a propellant that is propelled by an electric field. The ion drive operates by first turning solar energy into electricity, which is then utilized to accelerate ions out of a nozzle and produce thrust. It turns out that scientists have been working on SEP technology for more than 50 years, and many spacecraft, including NASA's Dawn probe, which is now orbiting the dwarf planets, use ion thrusters. The SEP drive will be employed on trips to Mars. The ion drive's drawback is that it only gives the spaceship a very little amount of momentum. Ion drives are among the most fuel-efficient spacecraft propulsion technologies, notwithstanding their slowness. For the Lunar Gateway, an outpost that will orbit the Moon, NASA is currently using a very effective electric propulsion technology. In April of 2021, the ion thruster system, which is around 30% more powerful than earlier designs, was activated by NASA. However, NASA began to consider nuclear pulse propulsion as a different way to propel a spacecraft fast to their target. There's been some interest in utilizing nuclear reactors to power spacecraft at the same time that nuclear jet engines for bombers are being researched. One beneficial factor is that they are dependable and do not require sunlight to survive in frigid, dark areas of space. The Zeus reactor might launch spaceships to other planets in less time and is intended to run for 10 to 12 years. But this propulsion technology also has certain drawbacks. Nuclear reactors aren't safe to operate, since only very highly enriched uranium can endure the extreme high temperatures. However, there's another setback for this kind of propulsion system, because the US has outlawed the use of highly enriched uranium for spacecraft propulsion if a safer alternative exists. Russia is currently preparing to launch a spacecraft with nuclear power that will orbit the Moon, Venus, and Jupiter. According to Roscosmos, the Zeus Energy Module, which is essentially a mobile nuclear reactor plant and is intended to create enough power to propel heavy cargo into space, will launch the space tug in 2030. A round-way voyage to Mars would currently take longer than 3 years. However, according to NASA, a nuclear-powered spaceship might reduce that time by a year. Currently, NASA aims to combine a lunar lander with a 10-kilowatt nuclear power plant and send it to the Moon as early as 2027. The USA has never launched a nuclear reactor into orbit, whereas Russia has done it with more than 30 reactors, and Zeus will employ a 500-kilowatt nuclear reactor to travel between planets. Some claim that we are still a long way from nuclear fusion, despite the possibility that it could transform everything. The best rockets now available are those fueled by propellant. Any spacecraft's propulsion typically requires some kind of propellant, although some techniques rely solely upon the sun. For many years, solar sails have been under development. But with the development of the technology, solar-powered spaceships are quickly approaching reality. The $7 million LightSail 2 was launched by SpaceX in 2019 using the SpaceX Falcon Heavy. It measures 344 square feet and has sails made of tear-resistant mylar. This substance experiences pressure when solar radiation strikes it, causing the spacecraft to move. So how quickly can it move? The answer is, it depends on how much sunlight is shining on the sails. Thus, the vessel will move more slowly if it is far from a star, and much more rapidly when it is close. What about warp drive, then? You might have heard that designing and building a warp drive would be impossible. That doesn't necessarily mean it won't happen. In reality, engineers recently declared that a real-world warp drive is now feasible. Yes, feasible. Researchers claim to have developed a physical model of a warp drive in a recent study. However, many have said the technique is impractical because of the enormous number of unusual negative forces that would be needed. We are all aware that the Star Trek science fiction franchise is where the phrase warp drive originated. The faster-than-light-speed warp drive used by the Federation generates explosive power by crashing matter and antimatter together. But how does warp drive work? Our current understanding of the warp drive is contributed by Miguel Alcubierre, a theoretical physicist who has become well known in his field. This drive follows Einstein's general theory of relativity to achieve superluminal travel by a local space-time contraction in front of the spaceship and an opposite expansion at the back. Theoretically, you wouldn't experience any acceleration if you were an astronaut inside the spacecraft wrapped by the bubble. But to compress and twist space-time and produce a bubble, the Alcubierre drive would require a ton of energy, likely more than is present in the entire universe. Despite trying to create a physical warp drive for the previous 10 years, NASA hasn't made much progress. But this brings up the most recent research. The world's first physical warp drive model was unveiled by researchers at the Advanced Propulsion Laboratory at the Institute of Applied Physics. The existing model relies on exotic matter or negative energy, both of which are either non-existent or impractical to create under the laws of physics as we know them. Instead of floating ships in space-time, this novel idea makes use of floating space-time bubbles. This new physical model takes advantage of the notion that space-time bubbles can behave any way they like while requiring nearly none of the negative energy required by the earlier model. Alcubierre even gave this new design a green light. But for now, this is only an idea, working on a theoretical level. Furthermore, the required mass is still rather large. But with this innovative new concept, warp speed travel is much more likely than we previously believed, even though a physical drive may not be a reality today or even in a century. Do you think warp drive will be invented in our lifetime, or do you anticipate it taking centuries? Please comment below with your thoughts, and if you enjoyed our content, please give the video a like and do subscribe to this channel. Please be sure to hit that bell icon to get more amazing videos like this one, and thank you for watching.